Hello everyone, my name is Gabriel Ganse. I am a co-founder and chief scientist at Furhat Robotics, and I am also a professor in speech technology at KTH in Stockholm, Sweden. So in this talk, I will be talking about social robotics in research and how Furhat can be used to study social robotics. So social robotics in itself is an emerging field. There is a lot of interesting application being explored in both academia and industry. So social robots are basically robots that interact with humans in different ways. And of course, there are robots that do physical tasks, as the ones that we can see on the left here. A robot helping someone to go to the bathroom that doesn't do that themselves, or a robot working in small scale manufacturing with someone instructing the robot to perform certain tasks. And then there are social robots, where the main purpose is to interact with people, to have a conversation and talk to people and help them with different things. So robots in public spaces, for example, that we see here, or the Furhat robot in this scenario being used in an educational setting. So conversational systems that can interact with you through conversation, has seen a very rapid market adoption recently, in the form of smart speakers or voice assistants, for example. And we can see, if we look at the numbers, that this increase has really been quite remarkable if we compare here with 2017 versus 2020 in the number of US households that have smart speakers. We also see that in, of course, the number of people who actually work with this. So this is the headcount at Amazon working on only on their smart speaker, and how quickly sort of this has increased. So of course, this field will engage a lot of people, and as we see social robots also taking similar kind of market share, there will be a huge need for people who know how to actually develop applications for these robots. And there is also a big need for doing research on how we can actually build these robots and how we can interact with them. And of course, this kind of development and market adoption that we have seen for smart speakers and voice assistants has been enabled through technology breakthroughs. So there has been a lot of research in the past 30 years or so on speech recognition, for example, which might be the most important reason for the breakthrough we have seen in speech interfaces. So this curve shows the error rate, the number of errors or percentage of errors you get from speech recognition. And you can see that in the early 90s, we had about 80% errors, which is clearly too much to be able to have a meaningful interaction with the machine. But with the development and the research, and during the past 10 years, especially with the development of deep learning, we can see that we are now at a level where you can actually build applications with this technology. And that's really amazing. And there is this quote, for example, as speech recognition accuracy goes from 95 to 99%, we'll go from barely using it all to using it all the time. Uh, so given this rapid development of speech interfaces, one might ask, so why social robots? We have these speech interfaces already, especially if we have robots that don't have arms or do any physical task. That might be a valid question. But one way of answering that is to sort of make a comparison of why would you meet with someone in person when you can equally well just call them on the phone. And I think it's obvious for most people that the setting we see here on the right is clearly more preferred than just talking to someone over the phone. Partly because we can very quickly look around in the room and we can read out each other's faces. We can see who is talking to whom and who is addressing who. We can have objects on the table that we talk about and refer to and point to. And just the fact that sitting together in sharing a physical space in itself enhances the quality and the enjoyment of the interaction. So as a research field on research on social robotics, it's really an interdisciplinary field. So on the one hand, we have the development of technologies that are enabling this. We looked at speech recognition, for example, the improvements there. but there are of course many different technologies needed. We need research on computer vision to be able to see people around the robot. We need natural language processing, and we need artificial intelligence, just to name a few of the relevant technologies. And we need research on the applications of these technologies in social robots, and we need to understand how to design meaningful interactions, and what happens when people interact with robots. What do the interactions look like, and how can we design these and evaluate these? And thirdly, of course, the research in social science is relevant. So psychology and linguistics and sociology. So we have to understand how humans work, how humans communicate with each other, um, and so on. So this raises a number of important questions, like how do we build social robots? How do we model face-to-face conversation using knowledge from humans? What are the practical applications of this technology? Um, how do users interact with social robots when we build them? How do we evaluate them to know whether they work as we want or not? And how can we use knowledge about human communication to improve human-robot interaction? And also, can we use social robots to better understand perhaps human communication? Can we use that as a tool to improve our knowledge about humans? So there's a lot of interesting questions from different fields. And we think that Furhat is an excellent toolkit packed with everything that is needed, regardless of which of these areas you are really interested in researching. Um, so, of course, these are complex systems. There are a lot of different components here, and maybe someone is just interested in doing research on speech recognition, but they would like to test that out in the setting of a human-robot interaction. Then this is a good toolkit. But maybe someone else is interested in looking at how do humans act with communicate with robots, and how do they adapt when they interact with robots, and how can we make the robot adapt to them? So you want to be able to build, maybe quickly build a prototype application where you can do that kind of research. So regardless of exactly what kind of research you do, we think this toolkit can be used. And there are different ways of programming Furhat. So we have the Skill API, which is an API based on Kotlin, which is also used for Android development. And with that, you can build full applications. So it includes a dialogue framework and everything you need to build what we call a skill. And then we have another API called Remote API that has support for any programming language, really, that you can think of. It's a bit more limited than the Skill API, though. But depending on your needs, that might be the right thing for you. And then we have the Blockly, which is the graphical programming interface that you can see on the right here, where you can move around blocks in a very easy, intuitive way. And that is, of course, limited to some extent compared to programming, but we think it's a great tool for prototyping and for education. We also have other tools. So to the left here, we see the logging tool that you have, which allows you to log interactions and study them afterwards, or maybe you want to download these logs and do some kind of evaluations of the interactions or improve the interactions in different ways. On the right, we see another tool. We see the Wizard of Oz interface. So with this, you can build interactions before you have sort of fully programmed them. You can have a so-called wizard, which is an operator sitting in another room controlling the robot and seeing what the robot sees, and push these buttons that you see here in order to control the robot. And this way, you can quickly, again, prototype applications or doing studies on human-robot interactions without having to program the whole interaction and make it completely autonomous yet. And of course, then if you combine this with the logging tool, you have a very nice combination. So at KTH, we do use Furhat in many different projects, myself, but also colleagues of mine use it. I use it for this, you see here, it's a study on how we can achieve better turn taking in multi-part interactions so that the robot will know when to speak and not to speak, and how the robot can show that it wants a specific person to be the next speaker in the conversation. And for that, of course, it's great, and we have built this application that you can see here as a test bed to study that. In another project, we look at, can we build a robot that can present a piece of art to an audience and can adapt the presentation to the audience. So the idea is that the robot perceives the audience and see their reaction to the presentation, and we want to see if we can then see if we get kind of negative or positive feedback from the audience and the robot can clarify things in the presentations and so on. So that's also an interesting research project, I think. This is another one example. Here we're exploring whether social robots can be used as hosts on driverless buses. So in the future, we will have driverless buses, which is of course great for many reasons. But one potential downside is that if we remove all humans operating the buses, people might not feel safe anymore or might not know who can I ask questions and so on. And putting robots on these buses might be a way to actually help people out and increase their feeling of safety and so on. So that's also interesting. We're also doing research on language learning. So how can we use the robot to teach new languages? For example, immigrants coming to Sweden, learning Swedish, but also we are studying in Swedish school with children to learn English. So that's also, of course, interesting. Here is another example of a robot that helps to give instructions for cooking a meal, and there the idea is to study how the robot can give instructions and how people react to instructions given by the robot and how they can refer to things that they are talking about in the shared space. I also use Furhat in education at KTH, and my colleagues also do. So I'm teaching two classes. One is multimodal interaction and interfaces. We have around 120 students per class per year. The idea with that course is that we want to teach how you can combine different modalities such as augmented reality, speech, and so on. And of course, social robots is an excellent example of multimodal interaction. So that's one course, and then the other one is conversational systems, where we look at both speech-based systems, but also social robots, of course. And that in that class, we actually have a combination of PhD students and master level students. And we partly use Furhat in a lab. So we have 3 hours per student. They get to implement the tutorial we have on building a fruit seller robot. And there they use the virtual Furhat, so they can sit in a lab room and program. In the second one, we're in both of these courses. We also allow for group projects, and then the students can choose themselves what to do. But there, of course, Furhat is used by some students, or several projects are interested in that. And then they can come up with their own ideas of how to use Furhat. And they typically use both the virtual Furhat and the physical Furhat for that. So let's look at an example of what some of these students have built with Furhat.
Who do you believe is responsible for the murder?
Well, Francis and Albert used to play a lot of poker together.
How did you know Albert?
I was Albert's wife for a long time.
And in this second example, I want to show you a group where the students were interested in studying, can you detect user satisfaction or dissatisfaction from their facial reactions?
Hello. Welcome to the Fur Hat Cafe. My name is Fur Hat and I will be your waiter today. Are you ready to order?
Yes.
I am ready to order.
Okay, so that's it. Thank you very much for listening. If you have any questions, please feel free to contact me. Goodbye.